Chapter 9, Part 3. Definition: minimum effective concentration, or MEC. The percentage of concentration of the active ingredient in a disinfectant or chemical sterilant that is the minimum concentration at which the chemical meets all its label claims for activity against specific microorganisms. On the next page, page 170, figure 9.13 presents basic information about glutaraldehyde. Highlighted in blue, I'm going to read you the summary of glutaraldehyde. Summary of glutaraldehyde. Advantages: kills vegetative bacteria within 2 minutes. Bactericidal, gram-positive and gram-negative, tuberculocidal, fungicidal, and virucidal, and sporicidal for sterilization of killing spores. The soak time is 6 to 10 hours. The manufacturer's label for recommended use should be consulted. Disadvantages: noxious odors, good ventilation is required, unstable, 14 or 28 day product life, and dilution of product reduces the activity necessary for high-level disinfection. Uses: semi-critical items such as laryngoscope blades and flexible scopes, etc. Orthothioaldehyde, OPA, which will be referred to as OPA from this point on. OPA is a high-level disinfectant that provides a fast and effective way to disinfect a wide range of instruments. The OPA solution may be used and reused within the limitations indicated by the manufacturer for up to 14 or 28 days. The concentration of OPA solution should be tested with the strips recommended by the manufacturer before each use. If the solution falls below its MEC level, it should be discarded, regardless of how many days the solution has been in use. Following immersion in OPA solution, instructions for rinsing items should be carefully followed to ensure the chemical is completely removed. Care must be taken to ensure that the item is not contaminated. Figure 9.14 provides a summary of basic information for OPA, which is located at the bottom of page 170, highlighted in blue, which I will read you now. Summary of OPA, also known as orthothioaldehyde. Summary of OPA. Advantages: solution is compatible with a wide range of endoscopes and other medical devices. Requires no activation or mixing. 14-day reuse life. Can be discarded down facility drains in accordance with local regulations. Disadvantages: does not have a sterile label claim. Uses: semi-critical items such as laryngoscopes, blades, flexible fiber, optic endoscopes, etc. Next, hydrogen peroxide. Hydrogen peroxide is a broad-spectrum HLD, high-level disinfectant, that is available in different concentrations. As with other HLDs, hydrogen peroxide dilution must be monitored by regularly testing the minimum effective concentration, or MEC. Follow the manufacturer's instruction for use for specific instructions with hydrogen peroxide. Figure 9.15 provides a summary of basic information about hydrogen peroxide. I'm going to read you the summary of hydrogen peroxide located at the top of page 171 and highlighted in blue. Summary of hydrogen peroxide. Advantages: broad spectrum HLD, kills bacteria and viruses including norovirus, rotavirus, RSV, MRSA, and TB. Can be used as a sterilant at the right concentrations. Disadvantages: corrosive to some materials. Uses: disinfection of hard and soft surfaces. Parasitic acid. Parasitic acid achieves high-level disinfection in 5 minutes at room temperature. Some dilutions are designed to be used in a manufacturer-specific automated endoscope reprocessor, which is also known as AER, and as a sterilant only. Parasitic acid is compatible with many materials and can be used to disinfect laryngoscope blades and endoscopes. However, it is also known to be corrosive, so check the device manufacturer to determine material compatibility. Follow the manufacturer's instructions for use for specific instructions. Figure 9.16 at the bottom of page 171 provides a summary of the basic information about parasitic acid. Highlighted in blue, I'm going to read you that now. Summary of parasitic acid. Advantages. Broad spectrum high-level disinfectant, or HLD. May be used as a sterilant in the appropriate AERs. Automated endoscope reprocessor, AER. Compatible with materials. Disadvantages. Corrosive to some materials. Uses. High-level disinfectant of laryngoscope blades and endoscopes. Caution. Before using a chemical disinfectant, be sure to review the manufacturer's instructions for use. Using the correct chemical the wrong way is just as dangerous as using the wrong chemical. Safe work practices when performing manual disinfection. No matter which disinfectant is chosen, failure to use it properly according to IFUs will result in the failure of disinfection process, which puts both patient and staff at risk. Work area setup. Disinfection process should be performed only in designated areas separate from the area used for cleaning. The workflow should help ensure that items being processed are not recontaminated during or upon completion of the disinfection process. Any accessories needed for the disinfection process, such as measuring devices, soaking bins, and timers, should be collected prior to the beginning process. Labels. Since chemical disinfectants have different capabilities, it is important to read the product labels to ensure they are used appropriately. Check the IFUs of the disinfectant and medical devices to be processed to ensure compatibility. See figure 9.17 as an example. Disinfectants used in healthcare facilities are harsh chemicals. It is important to read and follow all safety precautions. Preparation instructions. In addition to choosing the appropriate disinfectant, there are various factors that are vital to the success of chemical disinfectants. When preparing disinfectant solutions, check the labels for essential preparation instructions, which include appropriate concentration for use, diluted or full strength, dilution or mixing requirements, correct temperature required for the disinfectant, and water quality and pH requirement. Important safety note. While manufacturers may combine chemicals to create a more effective disinfectant, CS technicians should never mix chemicals on their own. Some common chemicals can be lethal when combined. Contact. Disinfectants are not effective unless they make direct contact with all surfaces of the device. Improper cleaning will leave organic matter that prevents direct contact. Lack of contact through improper application or because soil remains on a device will result in failed disinfection process. Direct contact may also be impeded if items are not disassembled properly or if they are only partially submerged in a disinfectant soak solution. When disinfecting a lumen, care must be taken to ensure there are no air bubbles in the lumen that prevent the disinfectant from coming in contact with all interior surfaces of the lumen. See figure 9.18 as an example. Exposure time. Exposure times vary by type of disinfectant. Many times, the term wet contact is stated in the instructions for use. This means the amount of time the device must remain wet with the disinfectant. Use a timer to ensure the proper exposure time is met. What is wet contact time? Wet contact time means the item must remain wet with the disinfectant for the entire stated contact time. If the disinfectant evaporates or the item is allowed to dry before the total contact exposure time is met, the disinfectant must be reapplied and the exposure time must start over. Rinsing. Disinfectants require a rinsing process. Pure water should be used to rinse disinfected instruments, with care being taken to thoroughly rinse all surfaces according to the manufacturer's instructions for use. Achieving disinfection using mechanical process. Sometimes disinfection is performed using a mechanical process. The most common mechanical process is the one carried out in the washer disinfectors. These automated washers provide a cleaning process followed by the thermal disinfection process. Thermal disinfection uses heat to reduce the amount of bacteria on items, such as surgical instruments and utensils. See figure 9.1 for an example. Water temperature is the key source of disinfection in any automatic washer that claims to provide thermal disinfection. The exposure time and temperatures used to achieve thermal disinfection differ by brand of washer. Check the manufacturer's IFUs and the water operator's manual for specific information. Definition: thermal disinfection. The use of heat to reduce the amount of microorganisms, excluding spores, on a medical device. Pasteurizers. Pasteurization equipment provides disinfection at water temperatures 150 degrees to 170 degrees Fahrenheit or 65 to 77 degrees Celsius. The temperature is maintained for a minimum of 30 minutes of exposure to the instruments. Items must be able to withstand immersion in solution and be thoroughly cleaned prior to placing them in a pasteurizing unit. Water temperature and exposure time must be closely monitored. Figure 9.2